In this video, we're going to use different past region questions from the Algebra 1 region to discuss how to write linear functions using different methods. Let's start with question number 26 from the June 2015 region. Alex is selling tickets to a school play. An adult ticket costs $6.50 and a student ticket costs $4. Alex sells X adult tickets and 12 student tickets. Write a function, f of x, to represent how much money Alex collected from selling tickets. So let's write down what we know. We know that the cost of an adult ticket is $6.50. We know the cost of a student ticket is $4. Alex sells X adult tickets. We know the number of adult tickets is X. And he sells 12 student tickets, so we know the number of student tickets is 12. And we want to write a function, f of x, to represent how much in total Alex collected from selling all his tickets. So f of x, the function, is going to be how much Alex gets, the total amount that Alex makes from selling adult tickets, total dollar amount for selling all his adult tickets, plus the total dollar amount that he gets from selling all his student tickets. And what is the total dollar amount that Alex gets from selling his adult tickets? He gets the cost per adult ticket, which is $6.50, times the number of tickets that he sells, which is X. Plus, he also gets the total number of dollar amount for student tickets, which is the cost for a student ticket, which is $4, times the amount that he sells, and he sells 12. So f of x is equal to 650x plus 4 times 12. Let's just simplify this a little. F of x is equal to 6.50x plus 4 times 12 is 48. So this is the function for f of x. Let's look at another question. This is question 16 from the August 2016 region. Kendall bought X boxes of cookies to bring to a party. Each box contains 12 cookies. She decides to keep 2 boxes for herself. She brings 60 cookies to the party. Which equation can be used to find the number of boxes X Kendall bought? So let's write down what we know. First thing we know is that Kendall bought X boxes of cookies. And then we know that each box contains 12 cookies. She decides to keep 2 boxes for herself. She brings 60 cookies to the party. And we want to write an equation for the number of boxes X that Kendall bought. So we want to write some equation that we could solve to find X. If you look at each of the answer choices, you'll see that they're all solved something equal to 60. So we want to write an equation for the number of cookies that Kendall brings to the party. And then that equation will be able to solve for X, which is the only variable, which is the number of boxes she bought. So how many cookies did Kendall bring to the party? She brought 60 cookies to the party. We know that Kendall bought X boxes of cookies, and in each box there are 12 cookies. So the total number of cookies that Kendall bought is 12x. And she kept 2 boxes for herself. If she kept 2 boxes for herself, it means that she kept 24 cookies for herself, because there are 2 boxes and each box has 12 cookies. So 12x minus 24 should give us 60. 12x is the total number of cookies that she bought. 24 is the number she kept for herself. And that should give us the number that she brought to the party. The total amount that she bought minus the amount that she kept for herself should give us the number that she brought to the party. if we would solve this for x, we would be able to see how many boxes she bought. And this is choice 3, 12x minus 24 is equal to 60. Let's look at another question. This is question number 16 from the June 2014 Regent. John has 4 more nickels than dimes in his pocket, for a total of $1.25. Which equation could be used to determine the number of dimes x in his pocket? So let's write down what we know. So we know the number of dimes is equal to x. So x is equal to dimes. And John has 4 more nickels than dimes. So x plus 4 is equal to the number of nickels he has. Number of dimes and number of nickels. And we know that the total dollar amount that he has is $1.25. This is the total money. We know that a dime is worth 10 cents. The dollar amount of a dime is 10 cents, and the dollar amount of a nickel is 5 cents. So we want to write an equation that could be solved for x. If we add up the money value of the number of nickels that he has, plus the money value of the number of dimes that he has, we'll be able to add that up to find the total number of money that John has. And that equation, if we would need to solve it, we could solve for x. So let's do that. We want to add up the total dollar amount of dimes plus the total dollar amount of nickels. And that's going to equal the total dollar amount in total, which is $1.25. The total dollar amount of dimes is the number of dimes times how much each dime is worth. Since each dime is worth 10 cents, that's 0.10x. Plus the total dollar amount of nickels. The total dollar amount of nickels is how much each nickel is worth, which is 5 cents, times the number of nickels that he has, which is x plus 4. And that is equal to $1.25. The sum of that is $1.25. Now we could switch the addition order, doesn't matter. We could switch this and rewrite this as and this is choice 2. Let's look at another example. This is question 11 from the January 2015 Regent. The graph of a linear equation contains the points 3, 11 and -2, 1. Which point also lies on the graph? In the previous 3 examples that we looked at of writing linear equations, we used a word problem to find which of the answer choices would be the correct equation to model that situation. In this question, we're actually asked to use 2 points to write the equation of a line, and then we have to see which of these points lies on that line. To write an equation where we're giving 2 points, we first need to find the slope. Any linear equation is in the form y is equal to mx plus b. So if we find the m, the slope, and we find b, the y-intercept, we have an equation for a line. And now we'll test choices 1, 2, 3, and 4 to see which one makes the equation true, and that's the answer. So let's first find the slope of 3, 11 and -2, 1. To find the slope, we're going to do delta y over delta x, or the change in the y values over the change in the x values. Change in the y values, the first y, which is 11, minus the second y, which is 1, over the first x, which is 3, minus the second x, which is -2. 11 minus 1 is 10. 3 minus -2 is 3 plus 2, which is 5. 10 over 5 is 2. So the slope of this line is 2. So our equation now looks like y is equal to 2x plus b. Now we need to find our y-intercept. How are we going to do that? We know 2 points on the line. They tell us that 1 point on the line is 3, 11, and 1 point on the line is -2, 1. If we plug in either of these points into this equation, y is equal to 2x plus b, we have an x and we have a y. The only variable we'll be missing is b, and we could solve that equation for b. So let's do that. Let's use the point 3, 11. And we're going to plug that point into the equation y is equal to 2x plus b. So for y, we're plugging in 11, and for x, we're plugging in 3, and we're going to solve it for b. 11 is equal to 2 times 3 is 6, plus b. We're going to subtract 6 to get b alone, subtract 6 from both sides. b is equal to 5. So our equation now looks like y is equal to 2x plus 5. Now we have an equation, but we're not finished answering the question. We need to see which one of these 4 points that they give us as the answer choices lies on this line. Let's start with choice 1. We have the point 2, 1, and we're going to plug it into this equation, y is equal to 2x plus 5, to see if it makes the equation true. So for y, we're plugging in 1. For x, we're plugging in 2. Is 1 equal to 2 times 2, which is 4? 4 plus 5 is 9. Since 1 is not equal to 9, this point does not make the equation true, and choice 1 is not the answer. Let's try choice 2. We're plugging in the point 2, 4. So for y, we're plugging in 4. For x, we're plugging in 2. Then plus 5. Is 4 equal to 2 times 2, which is 4, plus 5, which is 9? Since 4 is not equal to 9, choice 2 does not make the equation true, and choice 2 is not the answer. Choice 3. We're plugging in the point 2, 6. For y, we're plugging in 6. For x, we're plugging in 2, plus 5. Is 6 equal to 2 times 2, which is 4, plus 5, which is 9? 6 is not equal to 9, so choice 3 is not the answer. So we know obviously that choice 4 is going to be the answer. We can just test it out to make sure. For y, we're plugging in 9, then 2 times our x value is 2, plus 5. 9 is equal to 2 times 2, which is 4, plus 5, which is 9. 9 is equal to 9, so choice 4 is the answer. Let's look at another problem. This is question 13 from the August 2014 Regent. Which graph shows a line where each value of y is 3 more than half of x? So let's write an equation for this line. For this line, it would be for each y is 3 more than 1/2 of x. So let's put this in y equals mx plus b form just by switching these two values. Y is equal to 1 over 2x plus 3. And whenever our equation is y is equal to mx plus b form, m, in this case is 1 over 2, is the slope. And 3, which is b, is the y-intercept. So we just need to see which one of these graphs, choices 1, 2, 3, or 4, has a slope of 1/2 and a y-intercept of 3. Choice 1. We see already that the y-intercept is 0. It's not 3, so this can't be the answer. Let's try choice 2. The y-intercept is 3, so that's good. Let's find the slope. We're going to choose 2 points. Let's say this point and the y-intercept point. We always want to move our x values from right to left and put that in the denominator. So we're going to move from this point over here 2 units to the right. So our change in x values is 2. Then we need to connect to the other point, so we move up 1. And the slope is 1 over 2, so choice 2 is the answer. You could try choices 3 and 4, and you'll see that either they'll have the wrong slope or the wrong y-intercept, so choice 2 is the answer to the question.